We're here live on Coffee Break with Jenny and Bezi. Today we'll be talking to you about the rare genetic disorder, Rett Syndrome.
Well, how was your weekend? Weekend was great. Went to Vancouver, did some shopping. Oh, I love shopping. What did you do? I just had to run home. Oh my god, did you hear that Amy's pregnant? I heard that. Oh, but I really hope it's not a girl. Why? Well, she has a chance of developing Rett Syndrome. I mean, like 1 in 10,000 girls develop it.
Rett Syndrome? What's that?
You never heard of it?
Nope.
Well, it's a rare genetic disorder discovered in 1966 by an Austrian doctor named Andreas Rett. The disorder causes a sudden stop in the development of female babies' nervous systems between the ages of 6 to 18 months.
Tell me more. Tell me, I'm curious.
Well, kids with Rett syndrome usually grind their teeth a lot and can't really walk or speak, and they really don't keep eye contact. There's also autism, and many of them have seizures. The symptom that is unique to Rett syndrome is the repetitive hand and wrist gestures they make, such as hand wringing, or the continuous clapping, or even hand-to-mouth motions. And almost half the girls diagnosed with Rett syndrome are mentally retarded.
Wow, and how does this happen?
Well, it's caused by an altered protein found in the X chromosome called the methyl CpG binding protein,
Okay.
or simply the MECP2 protein. How proteins are essential to our body because like each protein signals something different to the body. To do something different.
So different parts of the body.
Exactly.
Okay.
So the MECP2 protein signals to the body to develop the nervous system.
Really? So you're telling me that if one protein in the body doesn't function properly, then it could lead to serious development issues?
Yep.
But if this protein isn't doing what it's supposed to be doing, then what is it doing?
Well, instead, the altered MECP2 protein is causing the gene that signals the nervous system to develop to not work at all. So, like, their brains aren't developing completely.
Really? And how though? How?
Okay, well look at a gene. At the beginning of each gene, there are CpG islands, also called methyl groups. These islands are groups of vertebrate DNA with many CpG sequences. These islands signal the gene to perform a process called cytosine methylation. This is when a 5-carbon of a cytosine nucleotide is added to a methyl group to create a 5-methylcytosine. This process attracts the MECP2 protein to it, which then attaches to the CpG islands. After binding to the CpG islands, it attracts other proteins to attach to it as well. When they attach, it causes the histones to deacylytize, which causes the histones to detach from the gene. Histones are important because they protect the gene, but if they're not there, then the gene can get mutated. When the gene is mutated, it can no longer develop the nervous system and is silenced.
Whoa. Wait, Jenny, hold up. What?
Okay, let me explain this to you in like normal terms.
Thank you very much. Thank you. Okay.
Well, you know our friend Becky.
Yeah, she's so deaf.
Yeah, exactly. This is exactly what I'm going to talk about.
Okay.
So yeah, our friend Becky. Let's use her as the gene that we're working with. We all know how much of a flirtatious babe she can be at times. Let's call these signals she gives the CpG islands, or the methyl groups located at the beginning of the gene. Remember how I said the CpG islands did a process called the cytosine methylation and attracted the MECP2 protein to it? Well, that's exactly what it did. And this is Jeff, the corrupted man in her life. Let's call him the MECP2 protein. When he sees Becky signals, he definitely goes after them. He'll bind to Becky just like the MECP2 protein binds to the CpG islands. When he binds with her, he'll probably chat her up, probably ask her on a date, all the things that guys do. While he's making his moves, his friends will join him. These friends are like the extra proteins that bind to the MECP2 protein while it's connected to the gene. And here are Becky's friends. They're like the histones. They care for her, they protect her, just like the histones do with the gene. But when Becky starts hanging out with a new corrupted crowd, her friends are no longer there for her. She's unprotected, just like the histones with the gene. When the corrupted protein binds to the gene, it deacylitizes the histones, causing them to unattach from the gene, leaving the gene open to be mutated. And this is exactly what Jeff will do. He'll corrupt Becky as much as he likes, knowing that her friends aren't there to back her up. And she'll never act the same way again. And this is exactly what happens to the gene. It doesn't work the way it's supposed to. In fact, it is silenced so it doesn't even work at all.
Oh my gosh, Jeff.
Yeah, I couldn't believe she saved them.
Why would she do that? Like, what's going on in her head?
Oh, well. We should call her.
Yeah,
for sure. Yeah, but anyways.
Anyway, I get it now. But that protein is evil.
I know, isn't it?
Well, okay, so Jenny, you explained how it works, but why does it only happen to girls?
Well, in the fetus, every baby girl inherits 2 X chromosomes, one from her mom and one from her dad, as shown with blue and pink. When the cell divides, it makes a copy of the X chromosome for each cell. When it's done dividing, each cell chooses which X chromosome it wants to work with. The other X chromosome is simply silenced. If one of the X chromosomes contain the altered protein, let's say the one that was inherited by the mother, and more cells decide to use that chromosome, there will not be enough healthy cells to make healthy genes to develop the nervous system. Thus, people get Rett syndrome. So the more the unhealthy cells the baby has, the more severe the Rett syndrome will be. But boys, on the other hand, only inherit one X chromosome and get one Y chromosome from their father. So it's kind of hard for them to actually get the disease. And if a boy does get an altered X chromosome, they usually die before they are born, or only live a couple years, because they don't have an extra X chromosome to make cells that properly function MECP2 proteins like girls do. And boys that do have Rett syndrome usually have another syndrome called Klinefelter syndrome, which is when a boy has an extra X chromosome, causing him to have 2 X chromosomes and 1 Y chromosome.
Well, have they developed a cure for it already, or?
Well, no, not really. Well, not yet, at least.
Scientists are trying to experiment with mice to see if they can somehow reverse the symptoms of the disorder, in hopes of finding a cure. In the meantime, there are many different types of therapies people can go to try and reduce their symptoms, such as controlling their hand movements using music therapy, or learning to walk and move with physical therapy.
Wow, I didn't even know such a disorder existed.
No, it's not good. It's really sad, though, to think of all those poor girls that have to suffer through it. I know. No cure?
No cure, too.
Yeah.
Well, the upside of it maybe is that you said it's pretty rare, that it only happens in 1 in 10,000 girls, so
That's true. And if you think about it, only 1% of the girls inherit it from their mom and dad.
Oh, I see.
The other 99% it just happens sporadically. Just kind of scary, so it could happen. You never know.
You never know.
Yeah.
Well, I hope Amy has a baby boy then.
Oh, me too.
Baby boys are cute.
I know.
Yeah.
What do you think she should name him?
Jeffrey?
No.
Jeffrey's a cute name.
No,
come on.
Come on. What about Bobby?
Bobby, Jenny.
Come on.
Thanks for tuning in to Coffee Break with Jenny and Bezi. Tune in next week when they discuss Alzheimer's disease.